Hi everyone. Today we're going to take a little bit of a deeper dive into lists in Python, and specifically we're going to look at enumerating a list, meaning iterating through it using an index in addition to the value, and doing some functions that transform sequences. Let's do a little bit of review to start with. So let me start with a list. Let's just do a simple first, second, third, fourth, fifth. Now remember, we can refer to specific elements of a list using an index. And when we index into a list, we begin counting at 0. So for example, if I print element 0, then that is first. The first element on the list is stored at index 0. And then if I print the element at index 1, that's the second element on the list, and so on. So if you haven't dealt with 0 indexing before, just remember the index is the number of steps away from the beginning of the list the element is. So list 0 is 0 steps away from the beginning, so that's the first element. And that index doesn't have to be hard-coded either. I can do something like x equals 3, and then print list x, and so the element index 3 is the fourth element on the list, right? Index 0, index 1, index 2, index 3, so that's fourth. It does take a little bit of time to get used to those indexes in some sense being off by 1. But again, when that gets confusing, you just have to go back to remembering the index is the number of steps away from the beginning of the list. All right, so now let's look at some ways of iterating over a list. So this first one we've seen before. It's a simple for loop, for value in list, and then I can print the value. And so when we run that, first, second, third, fourth, fifth. Now, instead of iterating over the value, we can also iterate over the indexes. So I can do something like for index in, and now what I need to do is I need to give it the range of values. So in this case, I want the index to range over 0, 1, 2, 3, and 4. So the way you do that in Python is with the range operator. We give it the first value we want, in this case 0, and then this is a little bit different, so write this down and remember it. The first value you don't want. So the first value we don't want is 5. Now if I just print the index, what you then see is 0, 1, 2, 3, 4. We start at 0, and then 5 is the first value we don't want. All right, well now I can tie this to the list. First thing I'll do is instead of printing the index, I'll print both the index and the value. And then to get the value, I will use that square bracket notation from above. So I'll say list and the list at the particular index. So now I can run that, and we can see the mapping of indexes to values in the list. And I'm actually going to do this one more time, but I'm going to generalize it a little bit. So in general, if we want to iterate over the whole list, this value here, what I have as 5, can generalize to the length of the list. And then I can print out the same way I did before. So think carefully about this, right? If I have a list with 5 elements on it, the indexes of those 5 elements are 0, 1, 2, 3, and 4. So the length of the list, the length being 5, is the first value I don't want as an index because the last value on the list has index 4. So this right here is a general pattern for iterating over a list when you want to iterate over the indexes instead of the value. And I'll show some examples in a minute of why you might want to iterate using the index instead of the value. Okay, so that means you have 2 patterns you can use. You have this simple pattern here when all you need is the value in the list. And then you have the second pattern here when you need the index or the index and the value. And what the index tells you is where the value is in the list. So if it doesn't matter where a value is, then you use the simple for loop that's here at the top. And when the problem you're solving depends on where a value is in the list, then you can switch over to this pattern. Now, I'm going to show you I'm going to show you a third pattern that's kind of the same thing as the first one. What this is just a shortcut. So this is the fundamental way to iterate over a list when you need to know where the values are. But if you want a shortcut, you can do this instead. By calling the built-in enumerate function with the list as a parameter, then the for loop has access to both the index and the value each time through the loop. And so the difference is now, when I want to add the value to this print statement, I don't have to explicitly extract it using the square brackets from the list. I already have it in that variable. So remember, this here in section 10 is just a shortcut for what I did in section 7. You're welcome to use either one. I will tend to use the shortcut version in number 10, primarily because that's what you'll more likely see in code written by other people, but you're more than welcome to use whichever one you're more comfortable with. And then one other thing to show quickly is you can change a list simply by reassigning an individual value. So I can do something like lst2 equals third instead of the word third. And so now if I run that loop again, you see here that the word third, third, was replaced with just 3rd. Okay, so let's see some examples of this put into use. So the first task is just to swap the first and last values on a list. So if you see up here, we start with 1, 2, 3, 4, 5, and now we want the 5 at the beginning, the 1 at the end, and 2, 3, 4 in the same order. Now, since we're just doing a single swap, we don't even need any loops here. So pause the video and see if you can figure out how to do that. Remember, the focus here is on using the square brackets to access the elements in the array you want, and also knowing what the appropriate index is for the first and last value. All right, so before we do this, there is a small trick. And so let me show you back over here what that small trick might be. So let me start with just 2 regular variables. So x equals 10 and y equals 15. Now I want to swap the values in x and y. First, let me show you the wrong way of doing it. So if I do that, I'm not going to get what I want. See if you can predict what I will get. Right? Do you have your guess? Both values are 15. Well, wait, why is that? Well, let's use the debugger to see what's going on. So we'll start by setting x and y. We can see x is 10 and y is 15. And now we'll set x equal to y, right? Think, what will that do? That will make x equal to 15. And now we'll set y equal to x. What will that do? Well, y remains at 15 because when I said y equals x, we had already changed x to 15. So we end up with y and x both being 15. All right, so what do we do to fix it? The trick is you have to save the value of x somewhere before you replace it. So if we look here on line 4, before you put a new value in x, we need to save the old value of x so we have it later. So here's what we'll do. We'll just save it in a temporary variable. So this is where we're going to save that value of x. Now we can put the value of y into x, so that'll put the 15 into the x where we want it, But now when we give y its new value, that new value is not in x, but it's in temp. So now if we run this again, x is 10, y is 15. Now, temp is 10. So we've taken that value of 10 and put it somewhere safe so that when we say x equals y, x now gets the value of 15, but we still have the 10 somewhere. And we can bring that 10 out and put it in the y where we want it. And now we have x equals 15 and y equals 10 the way we want. So we're going to use this pattern with a temporary variable over here. So take a minute and try this again if you didn't get it the first time. Okay, so we'll use that 3-step. We'll have that temporary variable, and we'll save the first value there. And now we'll put into the first value the last value. Wait, what is the index of the last value? Well, remember, it's the length of the list minus 1. So there's the length of the list minus 1. And now what do we now want at the end of the list is what we saved in temp. All right, so let's see if this works. Now, to do something a little bit different here, because notice this function doesn't have a return statement in it. This function doesn't return a value. This is technically a procedure. It's an example of a group of code that has a side effect rather than giving an answer. So I'm going to start out with a list, and for good measure, I'll print it out. And then I will run that function, and then we'll print it out again. And when I run this, we start out with first, second, third, fourth, fifth. That's what this print statement did. And then this function modified the list. It made changes to the parameter so that afterward it said fifth, second, third, fourth, first. So most of the time when you run a function, you're running a function to get an answer, to get a return value. But on occasion, you will write functions that have side effects. In general, it's easier to reason about and design code that uses the traditional functions, but we'll see examples throughout the course where this side effect is helpful. Just realize that you should look to writing functions first and using side effects only when the function isn't an efficient way of doing that. Okay, I will also mention one shortcut. So I will call that version 1, and let's see what we can do for version 2. It turns out that you can assign 2 things at once. So this version, where I'm assigning 2 values to 2 other values, will have the same effect. And here you see the trade-off, right? This code is shorter. It's 1 line versus 3, but it's a little harder to see what's going on. But if you like that trick, you're welcome to use it. The reason this works is because the part of the Python engine behind the scenes will calculate both of these values before assigning either of the values on the left. All right, so let's move on to task 2. So here's a very common use of indexes, and that is you might have a list of values and you might want to know where something is in the list. So here I have a list of names, Nick, Bob, John, and I'm asking where in that list is Bob? Is he at position 0, position 1, or position 2? And in this case, you can see that he's at position 1. And you could also use this index of to simply answer, is something on the list or not? So what do we do if I say, where on the list is Bob? And here we have the list James, John, George. Bob's not on the list at all. We need to give some sort of answer. And the conventional answer is, in this case, to return -1. So if you say, where on the list is something, and you get a negative number, that's one way of saying, well, it's not on the list at all. So think back to using this enumerate pattern, or the range if you prefer, and try to find what you can put in that for loop to answer the question, where on the list is the given value? Okay, now before we start writing this, remember there's a question you can ask about loops to help organize your thoughts and to give you a framework for the problem. So we have a problem with a loop in it, and here's the question. Can this function give an answer before looking at everything on the list? Or more specifically, are there situations where it can give an answer before looking at everything on the list? And well, yes. If the question is where on the list is Bob, as soon as you find Bob, you can have a return statement, and that's the answer. It doesn't matter what's at the end of the list if you find Bob in the middle. Now, also keep in mind that there are times when you have to look at the entire list, right? You can't claim that Bob is not on the list unless you've looked at everything in the list, because Bob might be at the end. All right, so let's put that into practice. So as we look at every item on the list, what do we want to know? So when I look at Nick, when I look at Bob, when I look at John, what I'm asking myself, is this the person I'm looking for? Right? If the item I'm looking at is whatever value I'm looking for, I now have my answer. That item is right here at the current index. So I'm done. I don't have to look at the rest of the list. But if the item's not on the list, I can't give up until I've gone through the entire loop. So if I don't find Bob on the list, I return -1. But that return has to come after the for loop. That's why it's lined up vertically with the for loop. That means when the for loop is completely done, then we can give up and say, nope, Bob's not here. Let's make sure that worked. So Bob is at position 1 in Nick, Bob, John, and Bob is not on the list of James, John, and George. All right, now let's look at task 3. Now we want to know, do the two lists have identical content? So these two do. They both have 5, 3, 2, 1. Same values in the same order. These two are not equal. They have the same values, but they're not in the same order. The second element here is 3. The second element here is 2. So those lists aren't equal. And these two lists aren't equal. They don't have the same elements because one's longer than the other. So two lists are by definition not equal if they don't have equal length. So if they're equal, return true. If they're not equal, return false. Try that out. So again, let's think about some high-level strategies to help you get started. And one is, are there any easy answers? Is there a way to very quickly say yes or very quickly say no? And well, actually there is. We're looking at it. If the two lists don't have the same length, we don't even need to use the loop. They're not the same. So let's start with that. Let's get the easy case out of the way. If the length of list 1 is not the same as the length of list 2, then we can just return false. It's that simple. They're not the same. Now, the benefit of doing this first is now we can assume that list 1 and list 2 have the same length. Because if they don't have the same length, we're done. We're not running the code. So now we need to look through the lists and make sure they have the same values in the same order. So we're going to need that enumerate pattern again, because in this problem, it's not just what the value is, but where it is. It matters that the value 5 comes first, because we have to make sure that it's first in both lists, and the 3 is second in both lists, and so on. So we are going to use this enumerate pattern. When you iterate over something, you can only iterate over one thing at a time. So you can iterate over the values of one list, or you can iterate over one set of indexes. There really isn't a good way to do both at the same time. Your loop has to focus on one thing at a time. And by your loop, I mean the mechanics of your loop. So we're going to go and we're going to say for index, and I'm just going to stick with the index here. You'll see why in a minute. In the range, so we're going to start at 0, and just like before, what's the first value we don't want? The first value we don't want is the length of the list. Now, this is what I mean by we can only do one thing at a time. We can only do this single range. We're not going to do like index 1 and index 2 at the same time. So index is going through the indexes in list 1. But this is going to work because list 2 has the same length. It has the same indexes. So we don't need to put list 1 and list 2 in this for loop. So fight that temptation. So now we're looking through the indexes in list 1. So if the index is 0, that lets us look at the first element in list 0. And what do we want to know about that? We want to know whether it's the same as the first element of list 2. What we're asking is the value on list 1 at the current index is the same as the value at that same index on list 2. This is why we don't need to mention list 1 and list 2 here. We just need that single index, and we're going to apply that same index to 2 separate lists. Now, what are we going to do if they're the same? Do we have an answer? Well, no. We can't declare the list to be the same until we've looked at every element on the list. But what if they're not the same? Well, as soon as we find 2 that aren't the same, then we know the answer's false. So let's actually ask a different question. Let's say, are they different? If those 2 values are different, then we have our final answer. We know we're done. We found 2 elements in the same position that have different values. The lists aren't the same. And like I just said, we can't claim that the 2 lists are the same until we've looked at every element on the list. So we can't say they're the same until after the for loop. We have to go through the entire for loop. So the return, again, is lined up vertically with the for. Right? So let's see if these work. So this list should be the same. It is 5321. 5321 is the same. If we swap a couple around, so same values, different order, those are not the same. Put it back. They are the same. But if we make the list different lengths, they are not the same. All right, so it works. So really take a look at this. Look at how we're using the same index in 2 different lists. It's a classic reason why you would use that range or that enumerate, because we need to tie the position from one list to another. And also focus on the fact that I am not trying to iterate through both lists at the same time. Not in the sense of using the mechanics of the for loop. I am just focusing on the index and then accessing both loops using that same index. If that idea doesn't make sense or doesn't sit right, keep looking at it and keep asking questions until that clicks. All right, task 4. We're going to change to a slightly different perspective here. So now we're not so much going to be enumerating the list. We're getting away from the position being important. And what we're going to do is we're going to transform lists. We're going to turn one list into another related list. So for example, I will take the list 1, 2, 3 and apply a mathematical formula to it. The formula 2x plus 1. So I'll turn the 1 into the 3, the 2 into the 5, and the 3 into the 7. This transformation is a really common pattern used in machine learning, used in lots of web apps, among many other things. Now, let me start by showing you the basics of what's going to make this work. And so what we're going to need to do is build a new list. I'm going to give you one list, and you're going to give me a different list back. So how do we build a list on the fly? And the trick is to use a method called append. So I'm going to start out with that empty list. And the way we build a list is by starting with this empty list and adding things to it using the append method. So if I print out the result of that append, what I have is an empty list at the beginning that now is a list with one element on it, apple. And I can do that again. I can append again. And now my list has apple followed by pear. So I have apple, pear, orange. I can append as much as I want. So I'm going to start with a list, and then I'm also going to have an empty list, and I'm going to add those transformed values one at a time to the empty list. So see if you can apply that here. So like I said, this is a really common pattern. So what we start out with is our empty list. I'm going to call it answer. So we have the list coming in, the 1, 2, 3, I'm going to call that LST. And then the list that's going out, the transform list, I'm going to call answer. And now what I need to do is iterate over the input list and put a new value on the output one at a time. Okay, so for this problem, position doesn't matter. So I can just use the good old-fashioned for value in list. So for the value, what do I need to do? Well, I'm going to transform it. I'm going to get a new value. And so what's the rule for the transform? Well, in this case, the rule is just that mathematical formula. So I'm going to take the value and multiply it by the scale and add the offset. And now what do I do with that new value? I'm putting it onto the answer. I'm appending it to the answer. And then, so question, can I give an answer before I've gone through the entire list? Is there ever a situation where that works? And no. If 3 values come in, 3 values come out, so that tells me the return statement is after or below the for loop. 1, 2, 3 becomes 3, 5, 7. How about 10, 21, 32? Let's see, what should that be? It should be 21, 43, 65. There we go. So again, very common pattern. And this is another instance of what I called earlier that accumulator pattern. I've got an answer being an empty list, and answer is going to accumulate the answer. It starts out as an empty list, and step by step through the loop, it gets closer to the correct answer. All right, now this is a quick aside. I showed you this before, and I'll show it again because it is so popular in Python. But again, remember, if you're not ready to digest this yet, you can just pass over this part of the video. This transform pattern is so common that there's a special syntax for it in Python. And what it is, what we're going to do is we're going to set the new list equal to a transformed list. So we'll use the square brackets because that's showing that we're building a list. And what we'll put in there is the iterator. So we're going to, so I called it my list here. So we're going to iterate over my list. So the first thing we'll put in that square brackets is the basic iteration. And then at the beginning, before the for statement, we're going to put in the rule for the transformation. So given value, what do we want on the new list? We want 2 times value plus 1. Now if I print out, we should again see the 21, 43, 65. What else might I want to transform? Maybe I just want the ones digit. So I have 10, 21, 32. Let me add a few more in here. 57, 98. So maybe I just want the value mod 10. So I'll turn 10, 21, 32, 57, 98 into 0, 1, 2, 7, 8. Okay. What you see is that this syntax is a shortcut for all of this. If you're comfortable with that, great. You're welcome to use it. If you're not comfortable with that, then just put this video away and come back and look at it again in a few weeks. Right, so now task 5, last task for the day. Remember at the beginning of the video, I said that sometimes we write functions where we put in some input and we get a different value back. We get an answer back. That's what we did here. But sometimes we might want that side effect. So here I have a list of values, but some of those values have mistakes in them. I want these values to all be integers. Now, I could apply the same pattern up here where I put in the dirty list and get a new clean list out, but maybe I need to think of it more like a filter. Maybe I just want to change the list so that it's bad going in and good coming out. So see if you can make a small change to this pattern so that it doesn't return the answer, but it just changes the list. And as a hint, remember that you can just simply reassign values to a list. And finally, to ask if a value is an int or not, you just call the type function. So type for whatever that value or variable is, and then you can ask if that type returns the value int. All right, give it a shot. All right, let's try it out. So we'll ask our standard sort of questions here. Do we always have to go through the whole list, or is there a quick answer? And in this case, there isn't a quick answer. We have to look at everything on the list. And then the other question is, do we need the index? Does it matter where a value is? And in this case, it does. I'll show you why. So I will use the enumerate. So I have both the index and the value. So what I want to know when I get a value is it one that we want to keep? Is it valid? Or, actually, I'm going to say it the other way. If it's a valid value, there's nothing we need to do. So what we want to know is if there's a problem. When is there a problem? There's a problem if the type of the value is not an integer. And so if it's not an integer, what do we want to do? We want to change the list. So we change the list using this pattern right here. So we're going to take the list, and where on the list are we making the change? We're making the change at index. That's why I had to use the enumerate. And what are we changing it to? In this case, we're changing it to 0. Now, another interesting thing, this function will have no return value because we're not returning anything. This is one of those functions with a side effect. It's going to modify the list. And one way you can indicate that is here where it says the return value is none. That's a way of documenting this function so anybody who glances at the code knows that it's not supposed to return anything. So let's see it work. So when I take my list and put it into this function, we should take out anything that's not an integer. So when I print it out at the end, the good values remain, and the ones we don't want are turned into zeros. Let me throw in a challenge quickly. Another thing we could have done is instead of turning those values into zeros, we could have made a filter function where those 4 values went in, but only the 2 good values came out. I will leave that as a challenge problem. Notice that I used the enumerate here and I used the index. I do want to show you, this is always dangerous, so I will mark it very clearly as incorrect code. But I want to show you what won't work so that you know not to do it. So you might be tempted to do this. You might be tempted to say, for value in list, if the type of the value is not an int, just set value equal to 0. But this doesn't work. The reason it doesn't work is not something I can explain on the video very well. It has to do with how Python uses something called references. So we will come back to that in the classroom where I have a whiteboard. But I want you to watch and see that if I write the code this way, it doesn't actually change the list. This does not result in different values. So memorize this as what we call an anti-pattern, and as an example of something that you make sure that you don't accidentally do. The rule is when you're using this for each loop, where you say for value in list, you cannot change value. Or more specifically, modifying that value will not change the list. But I wanted to emphasize this here primarily so that you don't try to do this and then get frustrated when it doesn't work. All right, so that's enough examples for today. Hopefully that gives you some patterns you can use and you can leverage this as you work on the homework. If you have any questions, you've got Piazza and email and Zoom, and just let me know what I can do to help.